Hello guys, today I come up with another video and today we are going to talk about the fatigue analysis and says how we can do the fatigue analysis and how we can set up the simulations in Ansys Workbench. So it's open. In the graphics user interface you can see I have two project schematics and here I have Gronda selected from where I have picked up my materials. I want for my geometry and I have exported these to my engineering data. So after that I have my geometry and let's move on to the model. So I have already run this simulation. So I have all these results. But for you to know how have you set up it, let's edit this step one by one and move on. So edit the model. I have a solid geometry and I have 3D CAD. Now by applying the uh, boundary conditions at the relevant joints and the points, we are going to and applying the load conditions, we are going to solve it this analysis for the fatigue analysis for the fatigue simulation. Okay, so so this is my geometry. You can see. Okay, sorry. So I have this geometry. These are different parts of my geometry. Project wheel bar, project wheels, lid rod. Uh, this one is rod. Project wheel bar. This one down here. Project wheel. Project pedal. Pedal is down there. This one is pedal. You can see project lid. This top thing is lid. Okay. Okay, sorry. My mouse is okay. We can rotate it from here. This one is lid. This one is bin and so bin. Actually, in the particular scenario, there is my pedal down there, and I apply force here, and according to my geometry, this will open the lid, and the ball or anything inside this bin will pop out. So I'm going to solve it so that for how many times I could apply the forces down there on the pedals and without any fatigue stresses which could cause failures. We can also discuss about the safety factor. Okay, so move on to the materials. We have these materials. Structure stainless steel as well. This one is polyethylene, high density 30% gloss fibers. So for the connection is concerned, I have frictionless in the ideal case between the rotating part and bonded for the fixed connection between the ports. You can see this one between the wheel and the wheel bar we have bonded, and here we also have bonded connection between lids and these lid bars. I have this frictionless connection because lid could will move when I apply the force, and same. Okay, this one is also with the lid. So project wheel bar between the wheels. You can see this one is bonded. So you can figure these are my connection where there is rotating part. I have frictionless and where I want them the fixed boundary condition I have bonded. So this is my mesh and You can see I use the metric millimeter. 20 millimeter is my maximum size, and so sizing adapted sizing and higher. So for the elements and loads are concerned, so this is my ratio. Okay. So next is my setup for the simulation. So I have this structure. You can see I have fixed ports. So in the particular scenario, you can see I applied forces at 2 points. One at the pedal and the other one is the worst scenario is on my main. These are the distributed forces on the top surface of the main. So this one is my fixed board, wheels are fixed. So I apply force, it couldn't move. In the worst scenario, it should be the case. So this one is my force on the pedal, which is 133.45 Newton, and my fixed board again, the other wheel, okay, and force is force to 88.964 on the lid. So I have solved this simulation, and let's see the results. So this is the maximum equivalent elastic strain. Okay, total deformation. You can see third deformation. Okay, let's close this. Okay, now it's visible. You can see now uh, these points of high deformation. So is well figure. This one is the figure. I have figure. You can see now from my solutions. You can see I have used solution information. Okay, move to the analysis settings. So you can see I have a number of steps, one step and time one, and I have totally make it a linear solution because I have set the boundary condition accordingly, so we can look for the worst area, worst conditions of the loadings. Okay, stress to look for safety factor. You can see the safety factor. Some points down there on the portal pedals have low safety factors, and these giants of the bins also have safety factor less than one. So we need to add some materials at these points, or we can configure out the particular giant why the stresses are so high in the particular area, and if there are any bloods ends, we can chamfer or fillet them, or we can add some more material at the particular stress point. So you can see these are the points of high stress down there on the pattern as well as these end points of the rays. So you can see image. This one is also same. You can see it's somewhat clear here in the image. Okay. So for the life, you can see these points, these safety points, stress points where we have now seen the maximum stresses and safety factor is less. The life is also less at the particular point. So when we will be considering design, we are considering these points. Life is 1 e to power 6 maximum for the maze, and for these particular points it's about 100 cycles and 10 100 cycles, so we definitely need to consider it when we are designing it for 1 million times cycles. Okay, so you can see from this figure it's more clear. So the next is a figure of our safety factor due to fatigue loading. You can see due to fatigue loadings, the life at this point, this hinge point is this level, this hinge point is less than 1, and we need to reconsider our design and add more materials, or we can so particularly in this case we need to strengthen these points of engagement. So this is how we do the fatigue analysis, and I have talked about the boundary conditions, and you can see okay, one more thing. The tool you can see I have used the mean stress theory here, Goodman mean stress theory. So from this graph, you can see here is endurance limit, and then it moves to zero, and then it moves to the max. Hence, due to fatigue loadings, it will start the life cycle start to decline, and it end in the particular in this graphical scenario. Good man, this one, and then we have other also uh, other options which are sort of about Gerber and SB elliptical mean stress curves. Everyone is explained here. So you can see according to this particular concept, we are solving the particular problem. So okay, thank you very much.